Good afternoon, everyone. We are just going to wait a few minutes before we get started to allow everyone time to join. I'm just waiting for my colleague to share the presentation and then we'll get started. But welcome to our Drinking Water Wise webinar. This is our final webinar of 2025, and we're really looking forward to hearing from our guest expert.
Hi, Marika. I'm not sure if you can hear me, but I am experiencing some technical difficulties. Can you guys hear me?
Yep, we can hear you.
Okay, perfect. I think if you want, Jason, I am happy to do the presentation if you guys can hear me. Um, and if you want to just hit the slides, that would work for me. Alrighty.
Yep, that works.
Okay, so hello everyone. Welcome to our Drinking Water Wise webinar series. Today our topic is karst and source water protection, and I'm your host Natasha Matthew from Quinte Conservation, and I have with me today Trent, Marika, Jason, and Thomas. They are from Lower Trent, Rideau Valley, Cataraqui, and Niagara Peninsula Conservation Authorities. They're going to be helping us with moderating the chat, answering questions, and providing some technical support if needed. So on our next slide, we're just going to go over some basics. So I'm just going to mention some housekeeping items. The webinar will be recorded and it is going to be available on YouTube following today's live session. We ask that all participants are muted and your cameras should remain turned off. If you do wish to participate, there is a Q&A function, and one of our panelists will address your questions as they come up, and we'll try and make sure that we ask questions that are relevant to this topic today. Other than that, if you have any technical difficulties, you can message Marika at marika.livingston@mrsourcewater.ca, and I believe that will be in the chat shortly. So we'll just go over the agenda for today. So we're going to introduce source water protection, so just a quick presentation, and then we're going to hand it over to our expert, Kevin Slaine, and we'll do some question and answers after that as well. So just a short little bit about source water protection. So in Ontario, we have protection for municipal systems under the Clean Water Act, which was established in 2006. We have a multi-barrier approach to protect drinking water through locally developed source protection plans and risk management services. On the other hand, when you look at private systems, we have something called the best practices for source water protection. This is where owners of their private systems will try and do activities that will better protect their personal drinking water supply. So now that we know about the protections in Ontario for some of our residents that they rely on, we'll talk a little bit about the best practices for source water protection, which are for private systems. So the best practices are a voluntary guidance document that the Ministry of the Environment, Conservation and Parks has put together with the goal of protecting drinking water services that are private. and those systems are not protected by the Clean Water Act or a source protection plan. The document will walk the reader through how to identify vulnerabilities of their drinking water system, potential risk, and how to manage those risks, and provide actions for better protection of their drinking water source. It also includes lots of useful information, including for municipalities, private residences, and other agencies that are associated with drinking water. So at this time, I believe a link will be put into the chat for the best practices. So now that we know a little bit about what they are and why they're so important, the best practices were created initially because there is a bit of a gap between municipal systems. As you can see on the left here, there are a bunch of different steps to make sure that your water is clean and safe for you to consume. And on the right, it's the private systems. So when you look at the private systems, the parts that are X'd out are actually the parts that the owner of the system. So if you own a well, this is what you have to kind of do yourself. So you have to do your own water treatment, make sure that you're knowledgeable about what needs to be done to make sure that your water is safe. And it's recommended that you test your drinking water. And obviously, it gets distributed to your home to make sure that all of those pipings are good too, as well, making sure that. So there is a bit of a gap. So the best practices was made to kind of remove those gaps a little bit to try and help train people and educate them on their responsibilities on how to protect drinking water sources for themselves. And then why they're important. So they help when protecting human and environmental health. They extend the life of your drinking water systems, and it can actually help avoid the high cost of cleaning up a contaminated source, seeking out a new source if one of your wells gets contaminated. It increases your treatment needs. So, like, it helps you understand if you need treatment for specific contaminants that are in your drinking water source. It also helps in land use planning decisions, and it increases public awareness and accountability for drinking water stewardship. So some of the things that you can see in the best practices, some of the recommendations that are used to help educate people with private systems. One of the main things is testing your drinking water regularly. The local health units will have tests for E. coli and total coliforms. So they're free. You take one from the health unit, bring it back home, fill it with water, and then send it off to the health unit within 24 hours. And they will test it and tell you a little bit about your E. coli and total coliform levels. So it's recommended that you do that around seasonally, just to make sure that your well is still free of those contaminants. Other things include creating an inventory of potential contamination activities. So this could be if you store road salt close to your well, maybe you should put it somewhere else. Same with pesticides. If you have a garden around or fertilizers, maybe you don't put fertilizers and pesticides near your well. And that kind of leans into the implementation of a protection zone. So making sure that activities that could potentially harm your drinking water don't happen, or they're outside of a zone to make sure that your drinking water is protected. Another important thing is to visually inspect your system, both your well and your septic system annually. This just kind of helps you be more preventative instead of reactive. So if you notice that there's something wrong or your lid's slightly ajar, that you can protect it before it becomes an issue. Same thing with septic systems. Typically, it's every 3 to 5 years. It does depend on the use and type of septic system you have, but pumping out your septic system every 3 to 5 years. And also using eco-friendly alternatives for commercial products. Some of the other things that you can do that are really important are conserving water when possible. Sometimes areas are in a drought and you don't have access to a lot of water. So when you're able to try and conserve it, if you have hazardous waste on your property and you just need to get rid of it, don't just throw it in your backyard. Please dispose of it correctly at hazardous waste depots. If you do have a fuel tank on your property, make sure that it is inspected and that you install double-walled tanks for fuel storage just to make sure that if there is a spill, it is still contained in that double-walled tank. And then lastly, if you are on a waterfront property, trying to implement a shoreline buffer to reduce the runoff that goes into the water bodies that your property is connected to. So these are just a few of the things that people can do who are on private wells or intakes, just to make sure that you're protecting your sources of drinking water, because it is all a shared resource that we have. So that concludes kind of a short discussion on our best practices, and now we'll turn it over to our guest presenter, our guest expert, Kevin Slaine. He has nearly 16 years of experience in hydrogeological consulting services and has graduated from the University of Guelph with a Bachelor's of Science degree in Earth Science in 2009. Mr. Slaine has been a registered professional geoscientist in Ontario since 2015 and has been working full-time with Terra-Dynamics, previously Terra-Dynamics Consulting, since 2010. Mr. Slaine is currently the Vice President of Terra-Dynamics, and he has work experience including Karst assessment, Karst remediation projects, water quality monitoring programs, hydrogeological studies and assessments, aquifer testing, landfill studies, water-based studies, or water balance studies, dewatering studies, and the applications with ministries of the Environment, Conservation, and Parks, including permits to take water, environmental activity and sector registry, and environmental compliance approvals. So he has a large range of experience related to Karst, and we're very excited to have him here with us today. He has worked on approximately 25 Karst projects throughout Hamilton and Niagara region. So without further ado, I would love to welcome Kevin Slaine, and we're very excited to hear what you have to say.
That's right. Sure, that's good. Okay, so thanks for that introduction. As mentioned, my name is Kevin Slaine, Vice President at Terra-Dynamics Inc. We're a hydrogeology company based out of St. Catharines, Ontario, with the majority of our projects being in the Niagara region, Burlington, Hamilton area, as well as Stony Creek. And a large number of our projects have dealt with Karst. So today I'm here to review and discuss the significance of Karst and Karst systems. So topics we're going to cover: what is Karst? Why is it important? Policies, as well as details associated with Karst assessments. And on the left here, we've got a photograph of a Karst string on the Niagara Escarpment. What is Karst? Karst is formed when soluble bedrock, so for example, limestone or doublestone, is dissolved by water containing carbonic acid to form unique landscapes for bedrock formations. So for example, when rainwater or surface water meets up with the soils or overburden materials, it'll pick up carbon dioxide to form weak carbonic acid, and it'll work to dissolve things like limestone and dolostone. And the photograph depicted here is just a spring that we monitored for a lengthy amount of time with a measuring tape presented there for scale. That's about 2 feet more or less. Some examples of karst features. Karst features include things such as sinkholes, depressional type formations, grikes, long and narrow voids within the bedrock, caves and conduits, which act to transport water through the bedrock environment, springs, which are emergence locations of water sinking in karst environments, as well as things like sinking streams, where the stream is directly losing water directly into the bedrock. And microkarst exists as well. Today we're going to be reviewing predominantly macrokarst or larger scale karst. Nothing as significant as many of you have likely seen in the news of roads or cars falling into collapses in Tennessee, Kentucky, things of that nature. But regardless, here's an example of some microkarst, some smaller scale karst from the dolostone core taken from Waterdown, Ontario, with a linear scale there. And even in smaller scale karst like this, it can work actively increase the transport time through the bedrock environment. Importance. Why is karst important? Well, first and foremost, it may be hazardous, and that's from several angles. It might be physically hazardous in terms of hazards to structures, existing structures, plant structures. May be hazardous for health and safety reasons, in terms of hazards for tripping and falling into, getting stuck in caves, things of that nature, pets or individuals falling into sinkhole type formations rather that are flooded with water. So the depth not readily apparent, for example. As well, karst can actively transport surface contaminants at great speeds through and into the groundwater environment. Alternatively, karst may or may not be overly hazardous or significant and allow for sites to accommodate certain types of development or redevelopment. And regardless, in my opinion, more awareness is needed, big picture wise. So dealing with karst hazards, karst is regulated by the conservation authorities and deemed hazardous sites, along with things like unstable slopes or unstable soils. Many engineers, municipal staff, developers, contractors, etc., are unaware of the unique challenges rather associated with karst hazards. I've been in many meetings where I get looked at as though I'm an alien, essentially, when reviewing karst-related details, as well as we've actually had to be retained for projects where lack of knowledge pertaining to karst has caused some notable issues. For example, on one project, a stormwater management pond was constructed and installed directly above an unmapped sinkhole, and the stormwater management pond was not lined. So essentially, we had just a pond that was leaking directly into the karst network. So some knowledge on that angle would have gone a long way from that particular group, leading to that spring associated with that sinkhole flowing at much greater rates than it should be, or examples of grading occurring at sites where people aren't aware of karst presence and essentially cutting off infiltration that's providing, important flows to down gradient sources with ecological impacts and things of that nature. So essentially, whenever development or redevelopment is occurring in a karst landscape, a karst assessment should be completed. Policies pertaining to karst. Some examples include things such as the provincial planning statement, which was updated in 2024, the Ministry of Municipal Affairs and Housing, the Conservation Authorities Act, planning and regulation policies apply, as well as any site-specific policies that should be taken into account. These policies generally recommend development be directed outside of hazardous sites. In the case of the talk here today, karst. However, this can be a challenge with rapidly expanding urban boundaries, as well as commonplace redevelopment activities. 50-meter buffers are typically applied around karst features and identified as hazardous lands. That's through the conservation authorities, unless a site-specific study can be completed to prove otherwise. This may avoid the need to direct development away from karst if these appropriate studies undertaken can demonstrate that mitigation or remediation of hazardous conditions is applicable. However, that requires coordination with the local conservation authority, as well as potentially permitting through the new Ontario Regulation 4124. Karst assessments. Next, we're going to delve into some important questions that should be addressed by karst assessments. So important questions to answer include things such as, is there karst present at or around the site? Are there karst features actively transporting water? Are there flooding hazards? Are there contamination risks to drinking water sources or springs or the environment in general? Are there ecological considerations in relation to karst flows that need to be taken into account? Are there structural hazards to site plans, erosional, subsidence, geotechnical, things of that nature, or even health and safety hazards, as mentioned in the intro? So is there karst present at or around the site? We'll discuss answering that question means to address that. On the right-hand side here, we've got a photograph taken. This is a sinkhole, so we've got some slumping of some clay overburden materials, some soil piping forming over a void that is present in the bedrock at that location. Mapping, site inspections, geophysical surveys, and geotechnical investigations should all be implemented to answer the question, is there karst present or at the site, around the site rather. In today's talk, I'm not going to be delving into much information pertaining to site inspections. However, they should always be considered in combination with these other methods to properly address the karst type landscape. So in addition to online mapping, such as through the Ontario Geological Survey, historical aerial photograph interpretation is very important. On this slide, we've got two aerial photographs presented. On the left, we've got one from 2002, and on the right one from 2012. And on the 2002 aerial photograph, a sinkhole formation is apparent sort of on the southwest corner of this building here. And it's got a channel which is inputting flows into this sinkhole feature. And then sometime in this 10-year delta between 2002 and 2012, essentially what happened here is a farmer in all likelihood has come and plowed the area, graded it, infilled it, and removed the vegetation. This is something we see oftentimes in a lot of our karst investigations where farmers sort of take matters into their own hands and try to address the hazard present on their site. So, implications of this are going to be reduced infiltration at this location. So, the thought process behind doing this might be to reduce the depressional hazard or to increase retention time of water on the site. But regardless, after this occurred, the infiltration will be slower and the feature will be transporting less nutrients actively as an interesting consequence. Other infilling contents include some miscellaneous type of debris that I see farmers applying. So that includes things here, such as broken up brick, rotted wood, old bottles, things of that nature. And these things, these processes that I see on job sites, this dates back to like the 1920s, 1930s, and that's just based on some dating of debris that I pulled out of various sinkholes. Geophysical surveys can be considered to identify and delineate karst. Electromagnetic or EM geophysical surveys, which measure electromagnetic induction for determining electrical conductivity of the ground for up to depths of 5 or 6 meters. These give in this scenario, low conductivity results can represent void spaces or electrically resistant bedrock. However, oftentimes voids can often be filled with clay materials in karst environments, which can lead to mixed results, unfortunately. Ground penetrating radar or GPR can be considered as well. However, this tends to provide even less reliable results in clay overburden environments. There's a potential for greatly reduced penetration depths as well as inconsistent values. So ultimately, given expenses involved in site decision making is required and needs to be considered critical. On the right-hand side here, we just have an EM or electromagnetic 31 geophysical survey that we've run. It's on a 10 by 10 meter grid. The green areas represent higher conductivity values, so thicker clay overburden, whereas the lower conductivity values are presented in red, representing shallower bedrock or potential void spaces. Geotechnical investigations are another critical tool. Drilling programs to confirm details such as depth of bedrock, quality of bedrock can be very beneficial. Test pitting is also important to incorporate depending on specifics of the study. Higher likelihood for karst conditions where the overburden is thinner in our experience, typically at overburden depths less than 3 meters. However, that's not always the case, especially when you're dealing with older karst formations, what we deem paleokarst. So another important question to address is, are the karst features actively transporting water? Are there flooding hazards? Obviously, as mentioned, water plays a critical role in the formation of karst features. However, through anthropogenic factors or natural factors, they aren't always currently actively transporting or infiltrating water. So that's an important question to answer. On the right-hand side here, we've got a sinkhole depicted that I've monitored that's currently receiving about 1.5 liters per second of flow in that photograph. And the orange flagging tape there is simply a data logger piece of equipment, which is about the size of a cigar. And we've got it installed there just to continuously record things like temperature, water level, to help determine things like how much water is infiltrating in this location. Here's just a photograph of a sinkhole receiving storm flow following a storm event. So in this photograph, it should be apparent that in a karst environment, contaminants picked up at the surface level will obviously transport quickly through the bedrock environment. Mapping out karst, dye tracing is a critical tool for determining this. This is actually the same sinkhole presented on the previous slide here, simply undergoing a dye trace process. And the importance of completing dye traces is to determine the emergence locations of applicable desinking water. And this can be completed using various techniques, fluorescent dyes, for example, rhodamine WT dye, which is pinkish red in color. This is the dye of preference by Terra-Dynamics Inc. As well as fluorescein can be considered. That's neon green in color, if you've ever seen photographs of that. These fluorescent dyes are non-toxic to aquatic life in the low concentrations used during tracing. There's a need to notify the appropriate parties when completing dye tracing. So the Ministry of the Environment, Conservation and Parks, or MECP, should always be notified via the spills hotline, and given various other factors such as the magnitude of the dye trace or the exposure to the public, other various parties should be considered for notification as well, including the municipalities or even in certain circumstances, the fire departments, the local fire departments. Traces can also be completed using salt in place of dye. It's not a standard preference by Terra-Dynamics, but just mentioning it here regardless. And for dye traces, you can couple visual inspections with digital results as well via the installation of scientific sondes, which will work to continuously record the concentrations of the dye. So on this slide here, we simply have presented a standard dye trace result as recorded by a rhodamine sonde. On the x-axis, we've got time. On the y-axis, we've got rhodamine concentration of the dye shown with the vertical blue bar simply just being the time of injection. This is sort of just a standard response curve during dye trace. And this is nice to implement on top of visual inspections just because it allows for a higher degree of analysis. Are there contamination risks to drinking water sources or springs? This is a big inherent risk in karst environments. Obviously, as mentioned, with the quick transport time through the bedrock environment and the ability to pick up contaminants from surface, this always needs to be addressed. So in relation to water wells in karst environments tend to be at higher risk due to various factors, including things such as a thin overburden, as well as a rapid movement of water exposed to at-surface contaminants through karst conduits with very little attenuation and filtration occurring. These contaminants include things such as bacteria or nutrients from fertilizer from agricultural fields, sediments, things of that nature, or even in more extreme circumstances, things like oil and grease or industrial type situations when inappropriate measures are being implemented near exposed karst features. And these contaminants at surface can reach the aquifer quickly or flow through conduits above the water table, higher speed velocities than in your typical bedrock environment. So all that's to say essentially that proper well construction with appropriate sealing, extended casing lengths, may assist with safeguarding the quality of well water. However, this is not guaranteed, and any well water with the intent of being used as a drinking water source in the karst environment should always be treated. So treating groundwater in karst environments sort of overlaps with the intro talk that was given here, but regardless, it's important to address possible contaminants through treating drinking water from wells. Methods such as ultraviolet or UV disinfection in combination with sediment filtration can be used to treat well water in karst environments. It's also incredibly important to complete regular groundwater quality testing, as results in karst environments can in fact be quite variable given the response to flows at surface and the quick infiltration occurring close to surface. So as a result of things like storm events and snowmelt events, as well as maintenance of treatment systems is critical. This sounds like a very common sense thing to include, but during our monitoring programs where we have to monitor private water wells and sample their well quality, both raw and post-treatment. An unsettling number of times we've actually had to have a situation along the lines of detecting some bacteria, going to notify the resident, have a discussion with the resident, only for us to be informed that, yeah, they have not been on top of maintaining the treatment system whatsoever. And for example, the ultraviolet bulb will be burned out or greatly overdue for replacement. So essentially, these treatment systems are only going to operate as intended if they're maintained. And in rural environments, consideration for cisterns can also be made as a source of drinking water. And in our experience, this is not always the case, but impacts to drinking water supplies has typically been a bit less of an issue for things like newer developments, given our current state of knowledge, hiring of the appropriate parties, testing requirements, things of that nature, but rather for older pre-existing properties and wells in karst environments. It's very common, for example, for older wells to have less than the standard 6 meters of casing, which can increase the likelihood of impacts from things such as shallow conduit flow, given the nature of karst environments. So this all goes to say that there's a high degree of importance placed on regular groundwater quality testing. Annually would be sort of on the lower end of what we would recommend, preferably 2, 3, 4 times a year, with a strong preference in karst environments, as mentioned, placed upon the spring season freshet, for example, when we have all the snow melting, as well as after significant storm events, precipitation events, where we're getting 20 plus millimeters of rainfall, for example, and to complete the well water quality testing in short order after these types of events, just given the nature of the quick movement through the karst network. And things such as study with groundwater quality sampling, consideration for including things such as total aerobic spore formers to prove whether infiltration into the groundwater from surface sources is occurring, in fact, to sort of supplement the standard bacteria sampling, which it typically includes E. coli, total coliform, and fecal coliform. Here we just pulled a figure which presents areas in southern Ontario with elevated E. coli risk. As mentioned in my intro, Terra-Dynamics has the most experience throughout the Niagara region and Hamilton area, so around number 2 there. But these areas, there is certainly an apparent overlap with well delineated and mapped areas with karst landscapes, so including places like Smithville, Stony Creek, Hamilton, the Bruce Peninsula, Belleville, Kingston, up near Cornwall in eastern Ontario as well. Case history, sewage spill. Just going to give some more example to contamination risks in a karst environment. So this is a man-made pond being fed by a natural karst spring. And this is an area where Terra-Dynamics rather had completed monitoring of a series of springs as well as water wells in a karst environment here. And unfortunately, there was a construction-related mishap where a sanitary line was ruptured essentially at gradient of this location, which obviously in a karst environment requires really quick response times. So an appropriate study team was assembled. Terra-Dynamics was retained to implement like a very thorough bacteria sampling program. A cleanup crew was enacted and enabled, and Terra-Dynamics essentially had to inform all the residents down gradient of the sewage spill there not to consume at any rate any of their well water or spring water at any costs while continuous bacteria sampling was implemented. And in this particular situation, obviously the Ministry of the Environment was notified as well. And this all sort of worked out well in the end. No reported illnesses or anything of that nature, but in a karst environment like this, a very quick response time is needed in events like this or mishaps like this. Are there ecological considerations in relation to karst flows? This is another critical component. So are there any karst-related flows providing necessary flows to ecological habitat or any thermal-related importance to ecological habitats as well? And to discuss this, I'll provide another case history file here This is an intercepted karst conduit within a sewer trenching line. We've got a toonie here presented with the red circle for scale. This is about 15 liters per second of flow entering the sewer trench here. And this is actually a deeper karst conduit, I believe 6-7 meters deep. And so there was actually some thermal importance to this water. And this was transporting water between 3 and 7 degrees Celsius thereabouts. And on this project, Terra-Dynamics had completed a lot of monitoring of the down gradient springs as well as the up gradient sink points. So there was actually some cold water fish habitat associated with a tributary where a spring associated with this conduit was feeding. So all this is to say that a very quick response was needed here, and a solution was needed to be implemented. The way this problem was solved was essentially installing a concrete box within the trench here, made of concrete, full of permeable material, to allow these flows to continue to pass from the up gradient location depicted here to the down gradient location at the springs, the appropriate springs, therefore not introducing any thermal related harm to the cold water fish habitat within a tributary here. So there can certainly be very strong ecological implications as well. Other structural hazards, site plans, things such as erosion, subsidence, geotechnical considerations, or even health and safety hazards, rather than as mentioned previously. The Ministry of Natural Resources and Forestry, MNRF, from 1996 has a hazardous sites technical guide, which sort of supplements some talking points today I've provided in relation to karst hazards investigations and assessments, as well as detailing some methods of addressing karst hazards in terms of improving or mitigating or remediating hazards with specific engineering type related recommendations, such as grouting or lean mixed concrete being applied to voids, or the bridging of foundations of structures over karst features. And further on remediation and mitigation, if a karst feature is not providing any sort of significant function, so as previously discussed in this presentation, including things such as significant flows or ecological benefits, things of that nature, consideration for remediation to eliminate or reduce hazards can be made. However, this requires close input from the local conservation authority, once again, via Ontario Regulation 4124, and as well requires close oversight and input from a karst specialist, whether that's a PGO or a PEng, in combination with structural and or geotechnical engineers. And on the right here is simply a photo of a remediated karst feature. This was not providing any sort of important flow or ecological benefit or anything of that nature. However, was imposing some structural risks to some development. So to remediate, some permeable material was placed at depth with some lean mixed concrete applied over at the top of the bedrock shelf here. Remediation, mitigation necessary. Here we're going to look at two different circumstances where one is no, one is yes. On the left-hand side here, we've got a very narrow karst feature. There's a bottle presented there for scale. And this was a redevelopment situation where there was an older building present on site that was taken down and a newer, larger building erected. And had this feature was unearthed during the construction process. It was reviewed by myself as well as structural engineers, geotechnical engineers. And as you can see, the feature sort of pinches out right by the foundations there. And ultimately, no remediation or mitigation were deemed necessary given the very minor nature of the shallow and small dimensions of this feature. However, on the right-hand side here, we've got an alternate situation to the need for remediation or mitigation. There's a box culvert shown here, and it was reported that flows were essentially sinking at this location and not passing through the box culvert as intended, which is not ideal for several reasons. You don't want, for common sense purposes, erosion or flows sort of undercutting the box culvert, as well as probably implying some ecological implications as well of flows sinking at a location. And this was looked at via dye tracing, and it turned out it was sort of emerging 30, 40 meters or so downstream of here. very close to the downstream side of the box culvert here. So in this particular situation, to remedy the situation at the bedrock shelf there, a concrete sort of cap needed to be applied to allow for some re-engineering to allow upwards to have flows essentially pass through the box culvert as originally intended. Karst assessments should also determine the need for karst contingency plans. Plans should always sort of be in place if karst is unexpectedly encountered during any sort of development activity. And a good example of that would be what I discussed recently there with the case study of the karst conduit being intercepted during a sewage trench process. And in conclusion, there's a strong need for municipalities rather and conservation authorities and even the general public to be aware of karst hazards. There's a lot of implications ranging from flooding, erosion, structural hazards, contamination hazards to drinking water sources and the environment, private water. While owners in karst landscapes should be aware of the need for treatment and frequent groundwater quality testing. Once again, given the variable nature of groundwater quality we see in karst environments, it is important, I'll hammer that home, to complete the frequent groundwater quality testing. Karst assessments should always be considered in karst landscapes. Here's some references used for today's talk. And I've presented my contact information here, my email, in the event that anyone wants to reach out to me directly with specific questions. But I'd like to thank everyone for attending, and now we'll be taking questions.
Amazing. Thank you so much for that presentation. We had a few pre-submitted questions, so I'm just gonna pull those up right now. And we'll go through those first, and then we will then go through the questions that have been submitted today through the chat. So we'll start off with our first pre-submitted question. Where can we find the latest karst location maps? And then do you have any other sources?
Yeah, sure. That's a great question for sure. Obviously, as I mentioned, part of the point of this presentation was to raise awareness, so that's a very valid question. Typically, the OGS, the Ontario Geological Survey, has a very good Ontario-wide mapping procedure that they've got. So they've got something called OGS Earth, which you can access online. And I would also recommend downloading Google Earth Pro, just because that way you can sort of download the actual KML files, for example, from the OGS website, download and import those into Google Earth. OGS has done a very interesting mapping process where they've got things such as known karst, inferred karst, or potential karst all sort of delineated across Ontario. And they've even included some interesting things such as photographs of some well-known karst areas there. So I would highly recommend that as well. In terms of other sources, in karst landscapes, there's things that can be relied upon, such as like sub-watershed studies in karst landscapes will typically include karst mapping and karst detailing. As well as things like master drainage plans, things of that nature would be really good to rely upon. And that should all be sort of available through, well, publicly anyways, through online resources. Obviously, hand in hand with this presentation today, the more mapping done and the more information gathered, however, it would be beneficial to sort of be continuously updating all of this and informing this to always be sort of expanding our knowledge in terms of areas with karst presence. Because, as I mentioned, there's certainly been projects where a lack of awareness on this front has been problematic, to say the least.
Yeah, that's a really good point, and it's really important to know what you're doing when you're doing it. And so having those resources is really important. I do believe one of my colleagues has put in a link into the chat where you can find one of those resources. Our next one here is, what is the best database mapping available for Eastern Ontario karst formation or locations?
So this sort of goes hand in hand with my answer to the first question. Terra-Dynamics, as outlined in my intro there, we specifically have a bit less experience working in Eastern Ontario. So I don't want to provide sort of exact comment on a lot of the, Eastern Ontario details. However, I would still definitely reference the OGS mapping that's been done, as well as anything available for your local municipality or your local CA. There's publicly available documents such as the watershed studies, for example, that will help to try to delineate these to supplement some of the OGS stuff. Publicly available reports online of works by others that have been documented and reported on in paper format as well. Yeah, that's what I would comment on that front.
Perfect. Thank you. Our next one are what are the compounding effects of karst and drought?
Well, to comment on karst and drought, essentially that sort of simplifies things when dealing with karst. If the features are not actively taking as much water, so if you've got drought conditions, you've got less precipitation conditions, so therefore you're typically not having these features actively infiltrating as much water. So I would therefore say you've got essentially reduced hazards during drought conditions of things being taken into the karst network via precipitation and surface water inputs. So that would once again be those contaminants I outlined in this talk, things like bacteria, nutrients, sediments, things of that nature, certain extreme circumstances, things that are not there than that. But yeah.
Awesome. Alrighty, next one is, does karst present a hydrogen sulfide risk to well water?
That's an interesting question. With a lot of our regular sampling we've done, as mentioned, talk here, we do a lot of karst sampling, water quality wise. So things as the nature of springs and karstic groundwater wells, things of that nature. Hydrogen sulfide, we tend to only really detect when we're dealing with much deeper karst environments versus a lot of the more sort of commonplace shallower networks that a lot of our projects have been involved with when we review our water quality in that sense. So that's what I would say on that. I think that would be more of a consideration probably for deeper karst networks versus the more standard and commonplace shallower networks.
Interesting. Okay, so our next one here is karst materials occur at varying depths below the surface. Is there a depth below the surface that karst will have less of an impact on groundwater?
Yeah, certainly, because essentially when you get the thicker overburden, you're going to have obviously less infiltration occurring into the karst feature. So, a lot of times we've dealt with, as I mentioned in the talk here, something called paleokarst, or it's a more ancient karst formation, and in our experience, it typically has thicker overburden materials overlying it. So, once you get to overburden depths 4, 5, 6 meters thick above those older karst features, it definitely becomes less of a hazard in terms of contamination transport. When we're dealing with these thin overburden scenarios is when we've got this much higher degree of risk to drinking water sources, for example, where we've got this thinner overburden of less than 3 meters, for example. We've got this higher likelihood of these features actively infiltrating and receiving or sinking water present at the surface.
That's interesting. I wouldn't have thought that that depth would just be 6 meters, but yeah, that's a great point. Next one is any advice on identifying potential groundwater under the direct influence of surface water wells without a geological report? Any best practices for distance from the surface water? So kind of similar to what you already mentioned, but if you have any other thoughts.
Yeah, certainly. If you're concerned about the status of your well, which is a good thing if you are concerned about that, as I mentioned, and I'll even mention this, based on our monitoring, we find some residents and owners of private water wells are, in fact, a little too flippant and unconcerned with the status of their water wells. We've certainly sampled and looked at wells that are constructed at very less than ideal conditions, essentially associated with them. So I'm glad that there's some concern being shown here. But yeah, there's methods outside of a full-on study you can implement. You can hire a water well contractor, for example, to come and inspect the well. That would be a good step to take, I would say, to ensure that you don't get anything. And that obviously has to go hand in hand with what I was mentioning earlier in terms of the water quality testing arm. It's important to always stay on top of that just to see whether there are impacts at your specific location. Mentioning Goody here, if you're close to a surface water location, especially, obviously less than 100 meters away or so from the surface water source, you've got that extra layer of concern. So obviously, on top of getting your well inspected by like a water well contractor or a hydrogeologist, things of that nature, I would definitely recommend being very much on top of your regular water quality testing, and just to ensure if you are treating your well, that is working in an efficient manner as well. Because yeah, we've even encountered, just to go in hand with what I was discussing today, we've even encountered private water wells that do not treat their groundwater at all, karst environments. So yeah, there's all sorts of various variables and situations.
Yeah, it is important, like you said, to test your water, even if you are doing treatment, because you don't know if that treatment's ever failing. So that is a really good point to bring that up here.
Yes, certainly.
Alrighty, well, without further ado, those were our pre-submitted questions. And we're going to turn it over to, I believe, Thomas, who is going to ask you some questions that have been submitted throughout today's presentation.
Perfect.
Thank you, Kevin, for the presentation and the questions you've answered so far. So we have a few more. The first one is about the dye tracers during a karst assessment. So do you use the dye tracers at every site, or is there certain conditions that would lend itself to using that method in particular, or the other methods you mentioned, like salt?
Yeah, certainly I can answer that. Yeah, at our company, it's fairly standard practice. And in our opinion, it's a little challenging to fully understand the karst network if you're not running those dye traces, if you're not mapping out every, it could be one emergence location, for example, it could be many emergence locations, but depending on the network of conduits or quays transporting these karst related flows. So whenever we're doing a karst assessment, we very much prefer to make the tracing process standard practice. It just really lends a hand to really get a thorough understanding. So that's essentially when we're doing the more advanced karst assessments, that is, we also provide sort of more basic karst assessments that look at things at a more sort of simplistic level. But yeah, but when we're trying to get those high level answers, it certainly is important to complete the dye trace, in my opinion.
Awesome. Thank you. The next question you've sort of already answered slightly, but it's about if you've ever completed work yourself within the Belleville, Napanee, or Kingston areas, and then it sounds like most of the work you've done, the majority of it has been in the Niagara, but if they're just interested in any thoughts you have specifically about those areas.
No, I haven't personally completed any karst assessments up that way. So yeah, obviously karst is prevalent in those areas, as I mentioned during my one slide here today. So I know it is a factor for strong consideration throughout that area for sure. But yeah, in terms of my own personal experience pertaining to karst, it's been essentially within the Niagara regions, within the Stony Creek and Hamilton areas as well.
Okay, thank you. The next one is about so the the question is if most karst was formed during the melt of the last ice age, or is karst actively forming today?
Well, yeah, so that's a good point. But yeah, karst is continuously forming and being altered essentially because that water essentially is acting to continuously erode. And that sort of plays hand in hand to why it's a hazard uh, and why we need to thoroughly map these things out and understand them. Because, for example, this is something I've encountered on several projects as well, is various parties potentially wanting to introduce or increase discharge or flows or infiltration into a karst feature. We always recommend against that. In that case, you're essentially increasing the erosional hazard associated with the feature, increasing the and expediting and the karst alteration essentially and formation. So yes, it's not as though karst is static and not changing anymore. It's constantly happening. Yeah, there's
Excellent. And then the last one is about performing a karst assessment. Would your team always work in a grid pattern for test pits or randomly test areas where there are visual signs? And um, I kind of want to piggyback onto this as well with a question of my own because I'm familiar with the karst geology map in OGS and how you have those areas of known potential and inferred karst.
hmm.
So, uh, if you're working in an area that's labeled as potential or inferred, and you don't see visual signs, would you still perform a karst assessment?
Yeah, and to answer that, it's going to be very site specific essentially, and so there's not going to be sort of one static approach. In our projects, we have to implement a wide variety of approaches. So, yeah, once you've sort of undergone the desktop study component, the site walkover component, looking at other studies around the area. Luckily, my own company has a good database that we can draw upon internally, even for karst assessments throughout the areas we've done work. We can sort of determine the likelihood and the need for doing something of that nature. So, yeah, essentially, what you can do is do sort of a preliminary karst assessment to try to answer that question pertaining to if you need sort of a very precise grid of test pits, for example, or if you just need a few generalized ones, or maybe you may not need any at all. It can be very variable, in my opinion. So it's all sort of dependent on what your findings are during the initial parts of the karst assessment to determine what sort of degree of intensity you want to apply in terms of the subsurface investigation components.
Excellent. Oh, one more just came in. In your opinion, should assessment for karst be included within the scope of a standard geotechnical report for new development, or does it need to be requested as a standalone study?
I think standalone is better. And as well, this is sort of like a wide-reaching comment, obviously. So, there's obviously areas in Ontario where a karst assessment really shouldn't be needed whatsoever. So, for example, if you're up on Shield Rock, for example, there's obviously not a need where you don't have those dissolution processes in the limestone, double stone, for example. But yeah, essentially, I believe they should be separate studies, just because the level of uh, analysis has to be a little different from a standard geotechnical assessment. That being said, there should be coordination between the geotechnical firm and the company running the karst assessment, certainly, because there is some overlap and some coordination needed, certainly.
Excellent. Thank you. That seems to, oh, well, one more just came in. I guess we could keep going. But, generally speaking, is the Onondaga escarpment not a significant concern because of the amount of overburden? So,
Yes, that is a good comment, actually. Yes, and that is correct. We were looking at that recently on a project down Fort Erie Way, I believe. And that is certainly the case. It seems to be more of a paleokarst type formation there, where you've got things at much more significant depths, which, as I mentioned earlier here in the question session, tends to be a little less hazardous. Typically, in terms of developments, you're if you are going that deep, then you can be taking into account things such as the structural hazard component. However, there's obviously a much lesser degree of contamination transport, typically when you've got that thick layer of overburden, especially when we're dealing with things like clay, which don't allow for a lot of active vertical infiltration, for example.
awesome. Thank you. Natasha, I'll pass it back to you for the wrap up.
Awesome. Well, thank you so much, everybody, for participating in our question and answers. And again, to Kevin for offering his overwhelming expertise in karst. Um, Before we end today, we just want to hear from you. Marika, I believe, is going to run the polls. It's just a few questions that help us make these presentations better and better every single time we do them. So if you have a second, we would really appreciate it if you could just fill out these questions. Um, there are 6 questions, and when you're done, just hit submit, and we'll take those results and we'll try and make our next webinar better and better. So we'll let that run for a couple of minutes. And as we do that, I'll just let you guys know that we have a webinar. Probably we're going to start doing them back up in 2026. This will be the last one for 2025. That being said, we don't know exactly what is going to be covered at our next one or when it will be covered, but if you have signed up for our email reminders, you will be notified as soon as we have information for you. So in 2026, we will see you guys again. And if you did miss any webinars previously, we have been doing them for just about 3 years now. So we have a bunch of them on the Quinte Conservation YouTube channel. So we've talked about cisterns, history of source water protection, climate change, harmful algal blooms, groundwater, septic systems, and much more. So if you're interested in watching any of those, they are available on our website and our YouTube channel. And then if you have any questions specific to your area, we have our 5 representatives on the call today, and these are our emails. I believe they will be put into the chat, but if you aren't from any of these 5 areas, please reach out to your local conservation area, and I'm sure they will be happy to discuss any questions that you may have regarding karst or anything to do with the conservation authorities. But without further ado, I believe that is our end of our presentation. Again, thank you so much to everybody who attended, and thank you so much to Kevin for all of your expertise and sharing some time and teaching us about the importance of karst and source water protection.